Hello everyone, welcome back to the channel. Today we are diving with the time series data set. In part 1, I am going to show you the step-by-step data analysis of the time series data set. I have picked up today the simple data set that is a totally perfect for the beginner, and if the professional want to brush up their skills, they can also watch this video. So my goal is first to build the strong foundation of the beginners who want to dive with the time series data set. Definitely in my upcoming videos, I am going to pick up the complex data set too. But I have divided this video too into the two parts. In the first part, I will show you how to do the step-by-step data analysis of the time series data set. And in the part 2, we will apply or implement the model 2 of the time series. Once you have a clear the steps and the process about the time series data set, then you can apply the same strategy to any data set. Okay, because you will have the strong foundation. And if you want to learn about the more deeper analysis, transformation, missing value, then you can watch my others videos too. Okay, in that I have explained in a detail how to transform the data, missing value, and so on. Today I have picked up the data set from the Kaggle that is perfect for you today. Store inventory demand forecasting. It contains the 913K records, 4 columns, that is date, store, item, and sales. So this data set contains the data sets of the sales from the 2013 to 2018. So it has the data set of 5 years sales, and we will do the step-by-step data analysis for this one. Okay. So we are going to perform these steps today. Data preparation, in which you will learn how to load the data set, handle the missing value, visualize the data to identify the initial patterns. Then we will slowly move on to the next level step, that is plot the time series data, calculate and visualize the rolling statistics, which is the most important part of your time series data analysis. And then we will also check the autocorrelation to detect the repeating cycles. And then time series decomposition. This is one of my favorite because we can decompose your data or the sales over the time to look at it very closely. Okay, so I am also using the Plotly today. If you don't know what is Plotly, this is a data visualization library. If you want to become master, you can check my data visualization playlist where you will find in detail about the Plotly. You can also watch that video. I will definitely share the link here too. Okay. So here I am importing the Pandas, NumPy, Matplot or Seaborn. Matplot, Seaborn or Plotly we are going to use for visualization. I have imported the Plotly further. If it is not installed by default on your system, then you can install it using pip install Plotly. I will show you how. I'm using the Google Colab, so I have also installed it. And then Pandas NumPy for data manipulation. So this is our data set. We are loading the data set here using the simple read_csv file. And then we are making the copy of the original data set because I don't want to make any changes in my existing data set to avoid leakage, to avoid any changes because if something happened, I need to reload my data set, so I can do that to avoid these kind of the mishappenings, or if sometime it happened, so we will keep a safe copy of our original data set. And then this is the first step of your analysis. This is the info method. Using this method, this is a Pandas method, you will come to know how many records you have, how many columns you have, what is the data type of each column. This is very important. Okay, and always do this. This is a part of your data analysis process. Either you are doing time series or either you are picking up the data set from any domain. Okay. And then head. This is also the most basic fundamental part of your analysis. It will show you the first 5 records by default. If you want, you can pass the numbers to 10, 20, whatever you want to see. The number of records. It is showing you the date. Look at this. The date is coming up with the year, month, and date. And number of stores. Did you notice here there is a no name of the store. There are the numbers actually. Okay. And then item number 2. There is a no item name, and then sales. Okay. Describe method will show you the statistics of each feature of the numerical. If you are interested to look for the categorical too, you can just pass the parameter include is equals to all. That's it. It will show you that one too. But date is not going to make any relationship, or it's not right now for me to too useful during these statistics of these all features. So I'm just using numerical one. It is showing total count, mean, standard deviation, and minimum value, maximum value. 25%, 50%, 75% is the statistics of the interquartile range based on the each feature. If you want to understand it, you can watch my statistics playlist. But this is going to tell you about its mean value of each feature. What is its maximum value? If it is very far away from your mean, this means there are outliers, skewness in the data set. This is the biggest advantage of to look for the statistics of the describe. Minimum value is 1. This is 1. There is a 0 value minimum for the sales. This means there is a one day when there is a no sale. Okay. And then we have a handling missing and duplicate values. So here we can use a is null method and check the sum of the missing values. There is a no missing value, we are lucky. Okay. And then duplicate. There is a no duplicate. If you found the duplicate, just drop it right now. There is a no use to keep the duplicates. But if you found the missing value and you don't want to apply the strategy to drop them, then just wait, because you need to split the data set first. Otherwise, there will be the data leakage. Okay. If you really want to know at a deeper level, again, watch my another data analysis like the end-to-end machine learning projects and the statistics part 2. Okay. Okay, so now let's start at a more like the advanced level, apply feature engineering method for the data. This is the most important step, whenever you are working with the time series data set, this is important. Just if it is coming in the categorical column, you have seen it is showing the object data type here, this one. So this should be your first rule. Whenever you found in time series data set your date and time column with the object, you need to convert it into the date and time actually. This is very important. Otherwise, you won't be able to draw your graph. This is a basic rule, fundamental rule. If you are a beginner, just fit in your mind. Okay. And then we are using the 2_date column here, this one. And then we will apply it here. Make the changes in your over the copied data frame EDA, and then look at this. It converted the object data type into date and time. This is important. Now you can separate the year, month, day, and day of the week easily. That's why we were doing that. Second thing, we need to draw the map, the graphs, right? For our stakeholder is interested to look over the sales over the week, over the month, over the year, right? This is the job of our time series data set. That's why we are working with it, because time series is the backbone of many decisions during the machine learning, right? So this is important. That's why you need to convert it. Okay. So this you can create these columns. So these columns are now created in your existing data frame. If you want, you can drop the date column. We don't need it. If you want to keep it, there is a no like the harm to. This is choices here. Okay. And then we have analyzer unique values for store and items. Although your store's name does not exist, but numbers exist. Okay, your stakeholder may be interested to know how many stores, unique stores, have in the data set. He want to see it in the insights. So you can use the unique method. Unique method does not bother about whether your data type is numerical or categorical. It will show you the unique or distinct count. So this means we have a 10 distinct store exist in our data set. Here we have a 50 distinct item exist in your data set. Then we will visualize the frequency of number sales per store. Now visualization is started. We are done with the basic step-by-step data analysis. In case you have the complex data set, definitely I will make the video too, where we have the categorical and numerical feature, both some missing value. So you can learn about that too. But right now, at a present, if you want to work with the complex data set, you have any data set in your mind, then I will share a link here. You can watch my that video too, where I am just like explaining how you can convert the categorical data into numerical. That's it. And you can combine these steps too. This is very easy. Okay. And then we are just to visualize the frequency of number of stores per. So it is showing all stores have the same number of sales. There is a no difference. It might be, right? Sometimes it's a different sales from the different stores, but it might happen same values. It exists actually in your data set. I can't do anything in this here, okay? Now we will move ahead with the numerical analysis. Okay, so here we have the sales distribution. We are just looking at the sales distribution. Okay, I'm using here histogram plot sales bins 30. I'm also like draw the kernel density to look for the this one, so we can look at the average sales and maximum scales. Here you can see on the x-axis we have a sales or number of unit sales. There is a frequency. So it is showing the not total sales. It is showing the units of the sales. Okay. Like the, let's say, so you have a 3 column. Okay. Right now we don't have these 2 column, which I'm going to make right now. This is actual price. This is discounted price. We don't have a these 2 column right now. We have a this column only, sales. So this is sales. Okay. So actual price is, let's say, $200 and discounted price is 150. So 250 minus 150, how many? 50. This is called sales unit. Okay. So this is we are looking at it. So you can like see we have so many records between the 150 to 200 sales unit. Okay. But their frequency is low. Okay. But we have some. Okay. Here you have the maximum sales unit between, you can say, 10 to 100 or maybe 60, then it is going down. Okay, so it depends how much discount you have in the data set. We don't have those columns here, but I just wanted to make you understand. So we are looking for that frequency. Okay, so this is the 50 unit sales, this is the 30 unit sales, have a highest frequency. Okay. This is for, we are just checking with the outlier box plot. So you can see, because there is a skewness, this is the outlier, this is the lowest. Like the records we have, this is between 125 to 200. And rest you have a very good amount of the your sales unit between this range. Okay. And then we will start with the actual visualization. This is the time series analysis. We are done with the basic one. You need to follow the same actually if you're working with this kind of data set, sales one. Okay. And then the best like the thing is, if you can make your index, set the date as index. This is going to make your life very easy when you are going to do the data analysis of your time series data. Okay. So I am going to do EDA dot set underscore index date in place is equal to true. We will make permanent change over this data frame. And then we are just showing the sales over the year. Okay. Look at this. So this is the most basic graph. But right now it is very messy, right? You are not able to understand anything. Your stakeholder will not able to understand anything. I just wanted to show you actually. As a beginner, students usually draw this graph, but don't try to draw this graph for your stakeholder. This is not going to make any sense because it's very hard for your stakeholder to look over this, right? How many sales are done? And I have drawn it just using your this graph, the plot. Now I will tell you the very useful insights using Plotly. Okay, so here we are just looking at this. First, we will look for the plot sales per day. It will, now we will divide it. Now you will see why we have converted over date column into date and time, and then why we have separated the day of the week month and your years. Okay, look at this. So here I'm importing the Plotly Express as a PX. You need to install it if it does not like installed on your system. I'm using Google Colab. I have also installed it. You can install it using pip install Plotly. Here I'm just picking up the group by the day of the week, 7 days. I'm doing group by day, day of the week. See, this is we have separated above, right? I'm using straightforward Nike column this total sales reset index. And here I'm just creating the name of the each day. Actually, I don't want to show the actually on the x-axis only the numbers of the day. I wanted to show, make it more interactive for the stakeholder. So I'm showing the name of the week. Sorry, day. So that's why I have created this dictionary, and then we are just mapping it based on the over this result. Sales daily day of the week dot map using the map method. This is existing method in Python. It will automatically map your results based on the day of the week. And then we are using the bar plot. Here we are using the data which we have created here. On the x-axis we will show day name. On y-axis we have a sales and then title and then the labels. Okay, and here category orders, and then we will show, look at this, Monday, Tuesday, Wednesday, Thursday. It's so easy for you to track for your stakeholder too. Look at this. This is, I have also added the tooltip. How? Using this one. Okay, so it is showing you the tooltip too. So here you, when you hover on that, it will tell you a day of the week and the total sales. This is 6.7 million sales. Okay, so here it is showing this. If you want, you can format the total sales with the 2 decimal too. You can add more formatting. If you want to learn at a deeper level, you can watch my Plotly playlist under data visualization. I will share the link in the description and notebook too. Okay, here it is showing you the total sales. This is so beautiful, right? When your stakeholder will hover on that, he can easily understand. And instead of showing just the numbers, always show the name. This is the second recommendation. It will not show you the day by default. You have to do that. Okay. And then we will plot the sales by month. Very easy. Again, we will do the resample. Resample is very useful method if you have already set your index as a date. It is very useful. And then month sales reset index, and then we will show it. Look at this. Markers is equal to true. I'm using this here. Okay. And then here we go. Look at this. When you hover on that, it will tell you the month, because otherwise if I don't show the month, your stakeholder will not able to understand like which month is this. See, sales. So this is so beautiful. It is showing you the trend over the month. If you want to look at this, in the month of July, you have the many sales, right? The total sales. So this means after the vacation, or maybe on the like you can say stat holidays like the Canada Day or any other day, you have like your stakeholder has the more sales. So you can show this, right? Before the holiday, after the holiday, when the sales are dropping. Look at this, in the January, in the start year of the month, then it start increasing. If you look at the trend here, look at this. In the first 2 months, sales are down, but as the month go up to the July, the sales are increasing up to the July. And in the July, this is a peak month of the sales, but it again start dropping, right? And again, there are more sales in the November, but it is dropping in the December, again this. So it is following the same pattern actually. Look at this, right? So you can tell, you can explain it very easily. What kind of the pattern it is showing, right? In which month sales are going in each year, and when it is start dropping. You can also like connect it with the holiday season too. Okay. So this insight is, this statistics is showing this one. Okay. Now heat map of the sales to check the correlation. This is very easy. I have just picked up the numbers. I'm applying the correlation method on numerical data and just plotting the heat map. Look at this. So now the day of the week sales, right? It is strongly correlated with each other. But others are showing the negative correlation. Some are negative, some are positive, but all are zeros. Only the sales and day of the week is connected with each other, right? And then trends and seasonality. This is the another most important. Okay. So above two, you were able to look at the like the trends over the time, right? You have seen at the start of the 2 months, the sales are down, then it is increasing, then down in the July, it has the most of the sales. So you can easily explain to the stakeholder, connect with the holidays. You can give them the reason. You need to talk to the domain expertise too, and you can also do the some research too. Okay. And then I'm using here make subplots of the plotly. Here we are using the daily sales, resample by daily sales. That's why I'm using D, and then decomposition. This is from your library stats model API. Okay. Because I'm going to show you the decomposition. This is one of my favorite. It divided it into the three parts actually: main, trend component, seasonal component, residual component. Observed sales I have printed. If you want, you can remove it. Choice is yours. Okay. Then we are just adding the space. This is a true. Here we are adding the actually hover on that for each one. That's why I'm using subplots. Figure dot add underscore trace go scatter plot x decomposition observed index. So it will first it will plot the graph for all your sales, observed sales we have in the data, and then lines, hover template. This is a tooltip. Okay. So rest for the other one is also same. Now look at the graph. Look at this. So this color is for observed. This is for trend, seasonal, and residual. Try to understand it carefully. This is the most important graph for time series data set. Definitely. Okay. Because you can see here the micro and individual season and trends of your sales data. Above it was the mixture, right? As you have seen in the here. You need to understand the sales, trends, seasons in a one line, right? As I have explained you, so you understood it. But if you look at it as a beginner, right? Or might be your stakeholder will look, he won't be able to connect it. Now we are dividing this graph into three different graphs at a deeper level, micro, granularity level. Okay. Here we will come here. Look at this. On the y-axis, it is showing sales and it is showing over the date the sales. This is the total sales actually. Okay. Now we are more interested in the trend actually. So now your stakeholder is interested in the trend, in which month it was the more sales. Here in the January, January this, July this, and we are showing this. So it is showing you the actually different trend. Look at this. In January, there is a here in 2013 it started the sales from actually in the 7 months, but you won't be able to see above, right? So it is very clear. This is showing you the trend. Now look at this. If it is going above here in 2014 in month of June, and then here it is going to start decreasing, right? And then here it is going up, right? And slowly little bit down here and this much. So it is showing you the trend over the month very easily. Separated, right? Your seasonal, your trend, your observed is not in a one graph. It is all in the separate graph. Okay. So it will tell you in which month how many sales are done for each day, right? It's a micro level for each day. See, 2nd of July, what how many sales and this. Above we were not able to see, right? And also showing now you want interested in the seasonal component. The negative sales means there were the no sales actually. Downline of the sales, okay? And this one, this is showing the downline of the sales of the each day of the month and then going up. It will show you the seasonal component. You can easily explain to your stakeholder what is the seasonal. This means every year in which month sales are down and sales are up, and average every year in which month. So it is almost following the same trend. Look at this. So no sales in the first these months, right? And then going slow up and then going come down. Okay. Then again here going down, right? So it is following almost the same trend if you look for the each month of the year. Okay. So this is very beautiful graph. Now this one is very, very useful for your knowledge actually. This contain the noise actually. Okay. Like some data points, right? In your data sets which does not follow any trend or anything. Sales are just going on, it depend, right? So these are these one. Look at this. There are some sales, okay? So this is the leftover actually sales which is does not belong to any specific trend, any seasonal component, okay? You can draw it for your knowledge actually. This is called noisy data, outliers, or the left, like the things which is not following any trend, which is not following any seasonal component. Okay, so this is for that one. So if you look at this, there are some, right? So this is too much noise. This is the variability of the data too. Okay, so this graph you are going to draw definitely. You have seen since the start, you have drawn the basic one, and then slowly you are dividing it into the sales over the day, over the week, and then over the trend, seasonal, and your residual too, right? So these all graphs by default you are going to draw. Believe me, okay? So even if you have a complex data set, you can draw the same graph, okay? No problem. Here I have just installed the Plotly. You can also use the same command. Now we will look for the like the daily sales in this. Look at this. This is only for the your daily sales and 30-day rolling average. Above we were just keeping up the each day sales, trends, seasonal component. Here your stakeholder might be interested to look for the 30-day average sales, like past 30 days, how the sales trends are going from the past 30 days to the current one. That is called rolling average. Okay, this the line which I have drawn here. Look at this. This one, date January 2013, the rolling average. We have set the window here. I will show you 30. This means 30 days. Okay, it will show you the each data point of will show you the 30 days sales of the each month. Okay, whenever you hover on the data point, it will show you the rolling average sales of the 30 days. You can change the window size here according to your requirement. There is no problem. Maybe you are interested only to look for the 7 days, you can make that. It is taking the average, it will take the average of 7 days instead of 30 days and show you the output. Okay. Here I am using again the Plotly for the your this one. Look at this. Here this data point showing February 2, 2013. So the 30 days, this data point on February 2, from the past 30 days, the average sale is 1467.72.67 million. Okay. And then going above like this. Okay. So you can check for each. If you want to keep the window like the small, you can also do that. You can take the only 7 days too if you want. Okay. Look at this. So it make more like the your smaller one. Okay. So you can also do that. It will show you the rolling average of the window size you have set. This is also a very, very useful graph whenever your stakeholder is interested to look for the average sales of some specific days. Okay, like 7 days, 10 days, 20 days, 30 days. We call it micro, like the sales trend granularity level of the your time series sales. Okay, and then we will move ahead. Look at this, the same graph with the standard deviation. You can draw it for your knowledge actually. Okay, if you want. If your stakeholder is little bit technical, then you can draw. Otherwise, you need to explain it as a non-technical way. Standard deviation is your variability of the data apart from your following the trend, right? So here you can calculate it dot standard deviation window 30, and we will plot it on the figure using at-trace subplots as I explained above. So now look at this. So it is showing you rolling standard deviation. There are some data points lie of the sales. Okay. Standard deviation is just kind of the variability of the data points lie in your data set. This is apart from your this one. This means your some sales also lie here apart from these data points. Okay. Range. Okay. If you want to learn it at a deeper level, you can watch my statistics series. Okay. But you can see it is also showing some like the here your standard deviation, rolling standard deviation of 30 days. Okay. Each data point. If you want to make it also the small one, you can also make it like for the 7 days this. Okay. So it will show you more clear. Okay. So there are some data points lie apart from your this sales range too. This means there are some sales exist between 0 to 2K, which is very far away from your these sales, right? So that's why we are drawing the standard deviation. But if you are not following the standard deviation, you won't be able to see these sales. Okay. And now we will move ahead, look for the autocorrelation function for the daily sales. This is very useful when you want to see the lag, like the difference between over the time the sales what like lag, like the units of the lag, like the difference. Okay. So I will show you. You need to use here ACF values. ACF, this is the inbuilt method, daily sales, and lags 30 days difference. Okay. Here we are just fitting on to the, this is FFT false, and then create the lag indices, this one. So we are just measuring the length of this one, and I will show you on the graph. Look at this. So it is showing the lag is 0 at this point, and here it is showing lag 1, autocorrelation 76. So this means it is strongly correlated with your sales 76% with the lag of 1. The difference between the sale is only 1 lakh, like the unit. Okay. If you look at this is the lag 2, and here look at this is 3, and this is in the next month, this is 4. So this means we are taking the window range of 30. So the lag of the previous 30 days, and in the lag is based on the previous 30 days. Like if in the January the sales were let's say 100K, and in the second month the sales are 120K. So there is a lag difference of 1. So this means your like the sales difference from the previous month is very less, right? It's almost same. But if you look at this month, look at this. It's a lag 6 and it's a lag 7. So here the sales are 7, autocorrelation 96%, but here 73. So this means there is a very much big difference, right? In the 30 days 7 windows, here the autocorrelation 73%, but here it is 96%. This means you have the less sales, and in this month there is a difference of your lag 7. Okay. So this is a just unit I am assuming, or based on the 30 days window size. Okay. Like how many sales are more or less than the previous 30 days in your upcoming month, or maybe the previous month. Okay. So we call it lag. Okay. So this is also the advanced level of the graph. If you want, you can draw. Otherwise, this is your choice. I just wanted to show you. Okay. Now here, look at this. This is also the lag graph. So this is a scatter plot. It will make you more clear. Above, I was not showing the total sales, only showing the correlation. But here you can see, here the date is not coming correctly. let me check here about the date, why it is showing the NAN. Right, so I have corrected it. It was missing here the daily sales. So we will create the new data frame, and in that we have just taking the window size for the lag shift is 7 days, and then create new data frame date, current sales and lagged sales, and then we will draw the graph. Now look at this, on the x-axis we have the lagged sales, on the y-axis we have a current sale. It will make more sense to you. We were showing the autocorrelation, the difference between the previous 30-day window size. Here you will be able to see the count of the sales too. Look at this. Here it is showing on the date of 21 January. The sales are this, right? So this is the, we are shifting the your sales from previous month to the next month. The difference, like how many sales were done in previous and in the this one and the next one. Okay. And now I will make you here, like it will make more sense to you. Let me show you. So look at this. So this is a Sunday, right? And this is Monday. I'm just taking the like a one example, okay? Day one lag, like the 1 day shift, okay? So let's say there were the sale 100. So first day it will be NAN because it is going to shift the sales lag. The difference is from previous sales on Monday, but it will not show anything because no, it will show something. Just give me 1 second. Okay, so now when it will show the here sales, let's say it will be this much. Okay, but now here, let's say 120 on Sunday. Then on your this day, it will pick up the 100. Okay, and 130, it will pick up the 120. So this means this is a shifting. This is a lag difference, right? For previous day to next day. And now I will clear all drawings here. Okay. So here it is showing this one. We have taken the window size of 7. So this means if the sales are on the 18th of February, the lagged sale was 1996 one, but the current sales were 1280.58. So your from your, if we go back, let me show you here. 12 this, we will hover on that. See, here it is showing this one, right, on the 14th of January. So the next your day, let's say 14, or there is a day of 15, or maybe after 7 days, right? So it will consider the previous 7 days sales too and show your current sales. This is the one. It is going to pick up your previous sales and show the current sales too. The difference, the lag, how many sales were done in the previous plus in your current sales, but it is also picking up the previous one to show you the difference. Either the sales were done less in the previous month or more, and how many sales are done in the your current month. Okay. So this is the like the lag plot. If you want, you can draw it. Choice is here. If you want to show the like the sales or your lag plot for daily sales. Okay. So this is also a very useful graph. Now look at this cumulative sales over time. This is very popular graph. I have used it many times in the COVID one too. It will pick up all sales from the previous months till the current date. Okay, let's say if you have a January to here, the total sales are of your $41,862 million. Then in July here, it has a total count from January 2013. Okay, so this is called cumulative. It will accumulate, pick up all sales from the previous month and keep on adding the current month sales into that too. But here it is not cumulative. It is only going to pick up the specific window month. Okay, this is the major difference. Okay, and you can calculate it using the cum sum method. This is very popular method. Okay, and rest we are using the simple over plotly method at trace. If you want to learn more about these things, you can watch my data visualization plotly, but this is very useful insight when your stakeholder is interested to look over the total sales over the each month or different months or over the year. So it won't show the only current results, it will also pick up the previous data along with it and show the total sales. Okay, here this is your lag one, and this is just the correlation. If you don't want to show it to the stakeholder, that's okay, this is just for your understanding. Okay, and then this is useful, these all are useful. Okay, so this was the like all about your basic like the step by step data analysis of your time series data set. Okay, and if you have any question, feel free to drop a comment. I'm always happy to help you. And if you like this video, please like this, and if you like this video, please hit the like button, subscribe my channel if you're new to my channel. If you like it, and if you give the feedback, it helps me in the motivation, motivates me to make a more useful videos for you. I really want you all, wish you a very good luck to transitioning into the AI. And if you need a help or you want me to make a video on any topic, just drop a comment. Okay, thank you so much for watching this video. See you in the next video in part 2.